subtitle anyways, how to get 1 million tons of emissions down to zero here in the GTHA. And that seems like a fairly big effort to try to do that. But in a few minutes, I'm hoping to sort of show you how that is not just possible, but I think even quite feasible. So, you probably have seen some version of this slide a lot, essentially telling us if we want a chance of a 1.5 C world, we're going to have to cut emissions by somewhere between like 50 to 65% by 2030. 2030 used to seem like it was far away. It's actually really close now. So, the question is, can we do this? And the this that I want to talk about is the emissions that come from building materials. So, usually at a boots on the ground event or when we're thinking about high performance buildings, we're really concentrating on the operating emissions of these buildings. And, people in this room are doing great work on getting those down low. We know kind of what the path to zero operating emissions looks like. So, it's like, okay, we understand that side of the equation. But about 10 years ago, I decided to try to figure out this part of the equation on one of my own buildings, and had one of those very scary aha moments where it was like, oh, the emissions from all of these materials are really big, and I wasn't paying attention to it, and I don't think a lot of people were paying attention to it. And so I've been on this sort of 10-year sidetrack of figuring this out in sort of more and more depth. So what we're talking about are these early phase emissions, the emissions that happen when you harvest raw materials for building products, drive them to a factory, and turn them into some sort of building product in a factory. There are other stages to the life cycle of a product, getting it to a job site, installing it, fixing it, end of life. But this part here is typically, for most materials, somewhere between like 70 to 90% of the full life cycle emissions happen at this stage before it even gets to your job site. So everything that I'm talking to you about is focused right here on these early emissions. And about 1.5 years ago, we did a study for Natural Resources Canada, where they gave us 190 model homes from across the country, and we kind of did this embodied carbon analysis on those homes. And what we found was, we put all kinds of materials to these homes. We did them in, northern Saskatchewan and in Quebec and in BC. But over the whole 190 homes, the average emissions was about 150 kilograms of emissions per square meter of floor area in the building. So, we got this number. It's like, well, great, that's a number. Don't know what that means. If we multiply that by all the square footage of low-rise residential homes that get built in Canada, it's 8.5 million tons of emissions a year across the country. So that's pretty significant. That's, 3 to 5 coal-fired power plants a year, the equivalent emissions just in making our residential materials, or like it says there, tailpipe emissions from 1.8 million cars. So it's not a small issue. And when we did the EMBARC study, what we found was that in the GTHA, the average was actually a little higher because homes here have bigger garages and use a lot more brick siding and a lot more XPS insulation than in other places in the country. And so instead of 150 kilograms per square meter, the average in the GTA was 191. And that means that, here in this region, it's, 840,000 tons per year. So just shy of 1 million tons. And we don't have enough information to calculate all the emissions from all the materials that go into a house. What we're calculating is basically the structure and the enclosure and the partitions. So we're not counting things like mechanical, plumbing, electrical, appliances, kitchen cabinets, millwork, all that kind of stuff, which is about another half of the total. So if we found 840,000 tons, the real number from everything that goes into a house is probably closer to 1.5 to 1.75 million tons per year, just from low-rise residential housing, just in the GTHA. So it's kind of shockingly big. But both studies also had this great side to them where we realized, if we just make a model of these same houses, we don't change the design, we don't change anything about them, but we just pick, first of all, the best materials with the lowest emissions that we can find here. They're code compliant, they're affordable, they're available locally. We can get a house down to 2 kilograms of emissions per square meter. That's a big difference, and that's really encouraging that we don't even have to wait for the magic solution to get to that. We can actually get to that with things that we can go buy at a retailer right now. And then we also made these models where we did what we called the best possible materials, and there we found that we could actually get a typical home into the realm of net carbon storage, and fairly significantly, like 50 kilograms of storage per square meter, which means instead of having any emissions, we could be putting 3 million tons of carbon away nationally and not contributing to emissions at all, which is a great sort of flip on the way things are going now. And so, what do we do to get those, those numbers from, 190 or 150 down a lot lower? Well, we can't really see it on the slide here, but we did 5 material substitutions. The first little green bar is the best available concrete. The next green bar is changing all the insulation that could be changed to cellulose insulation. The next green bar is changing all the insulation that we could change to wood fiberboard insulation to that type. The next bar is changing brick cladding to almost anything but brick. And the last one is changing things like drywall and flooring, not to a different type, but just to the best available product in that category. And this was one of the highest emission houses in the GTHA study, 262 kilograms per square meter, and those simple changes got it down to 66. So there's like a 75% reduction affordably and fairly easily from a typical house. So from all of the research, we sort of figured, well, I'm a home builder. I know how hard it is to change. I know that it's not, you don't just change quickly. So the stepped approach is we have to stop doing the worst of what we do right now. And the worst house in the GTHA study was 513 kilograms per square meter. That's half a ton of emissions per square meter of floor area in a residential home. And clearly we don't hit any of our climate targets at that. But if we start with our average, 191, all a builder has to do is try to take 10% a year off for the next 5 years, and they're here, which is great. That was the 116 was the best house in the GTHA study. And if they keep going, another 10% a year for another 5 years, we're down to 60. That's the example I just showed you, that great example that went from really high to really low. That doesn't seem that hard to do. Like each of those steps gave us more than 10%. So it feels like there is like a really great progression that we could make and encourage people to do. And then once you're on that track, well, you might as well just keep going because it's not that much. Now we have to go up because the numbers are getting smaller, so the percentage gets bigger. But 20% a year for 5 years gets you down to 0, and another 20% for 5 years gets you into carbon storage territory. So that's 20 years. That sort of sneaks us in right under the federal government's 2045. We got to be net zero by then. And so it really looks like if the home building sector takes this seriously, that there's a real path to being able to get this down to not just 0, but beyond 0. And I'll just wrap up this short section by showing you what a carbon storing house looks like. This is a project that we did a few years ago that we called Zero House, but that's a home with 24 kilograms of net storage per square meter, and doesn't look that different from other homes. I think we did it affordably and easily, and in fact in a sort of prefabricated method that made it pretty quick to assemble. So this is the trajectory that I'm hoping this EMBARC research really pushes the industry to go on, and that we aim our sort of sites better than getting to 0. Getting to 0 has kind of been a bit of a rallying cry in the building world, but I think we need to think, how do we do even better than that? How do we go sort of beyond 0? And this points to the fact that, we can and should do that.